Chris, you were most of the way there.
You know, I don't see how I could have moved from there. So I ended up going a different route.
Don't worry, I went different routes with 3 different tutors, and neither one of them could figure it out.
Yeah, something like that.
If you talk to Jack, he knows how to do it.
All right, here we go. We're all going to know how to do this stuff today.
And
Right now.
Lisa.
So this is this problem here.
Yeah. This is 102, 72. 7.3, 102.
I'm going to change one little thing just to make this, and you can do this anytime you want to in your own work. Any math class you take, as long as at the end you bring back the original letters. S is not a good letter for me for several reasons. Looks like a 5. If I put it in front of sign, it's going to look like I'm just trying to have some kind of a weird lisp or something, or some kind of, I'm a snake, or what the hell am I trying to do? So I'm going to call this D for right now instead of S. Now when you get to calculus, D is a bad variable, because you got like functions that have D's in them. Exactly, D of X, D of Y, all kind of stuff. But for right now, we're not in calculus, we're in pre-calculus, so we can do that. Here's A, B, and what are we going to call this whole side here?
C.
That's an awesome idea. This little dude is
C1.
That's crazy.
And C2.
Alright.
C3PO.
Alright. So you start just writing whatever you can. Now one thing that comes out of this problem that's really good and important to realize is a mistake people sometimes make is you try to write ratios from different triangles and make them equal to each other. The law of sines applies to one triangle at a time. Right? So I can't say like sine B over B equals sine A over D or something.
B of D, maybe.
Right? Because that's from 2 different triangles. It's really simple when you have a problem like this to do that to yourself somewhere in the middle of your work, and then you ain't never going to get there. So whenever you're working with a triangle, work with one triangle alone until you've sucked everything you can out of it, and then go to the next triangle. So out of the big ass triangle, what's this angle? 2x. I love it. So what ratio can I write there for the big ass triangle? B, A, T, the big ass triangle. What ratio can I write there? Sine of 2x over C equals what, for example?
Sine of A over A.
Sine of A over A. Now instead of just making it one big line like the rule is, the rule just does it so for space. Let me write it again. Sine 2x over C also equals
Sine B.
Sine B over B. Is that cool so far?
Yeah.
And again, you're just collecting stuff that you can see from the picture. One of the evil things about a problem like this, you see the answer, but the answer is so far away from the beginning that looking at the answer is only going to mess you up. You're going to try to create what the answer is doing. No. You have no idea where the answer looks that way. So you have to go the other way. Assume you know nothing about what's supposed to happen and just start writing everything you can. And then what's the last thing I can write from the big triangle? What's the last relationship I can write? If that equals that and that equals that, then these are
Equal.
Okay. Okay, that's the big ass triangle. What about, we'll call this from triangle 1 because it's got a little 1 on it. So what about from triangle 1?
Sine B of D. Sine B over D.
Alright, so I got sine of B over D
Equals sine A.
Don't even worry about this.
Oh, okay.
Let's talk about x.
Okay.
Sine x over C1. I like it. That's about it. That's really worth anything. I don't really care about that angle there. And what about from triangle 2?
Sine x.
Sine A over D.
Sine x over
C2.
C2.
Equals sine A over D.
Sine A over D. I like it. And what's the whole point of this problem again? What are we trying to figure out? We're trying to find D. I like it.
The equation for D.
I like it. And what's one last relationship I can write based off of how we defined, which variables did we bring into play here?
C1 and C2.
Yeah, that wasn't there. We brought that in ourselves. So what's true about all this?
C1 plus C.
C1 plus C2
Equals C.
equals C. All right, that's going to become important. So this is just, you don't know what's going to be important. You don't know what you're going to use. You're just going to write down everything that you can see. They said use law of sines. You're like, all right, dude, I'm going to use law of sines like crazy. What the hell? It's the only thing they told me. So shit, I'm going to do it. So, what can we... Now you start to look, okay, can I use stuff from each other?
Yeah.
Substitute.
You can either solve for D or solve for C1 and C2 to get your C.
Cool, I love it. So we know this. So I know I want to solve for C1 and C2. That kind of makes sense. Because then whatever those expressions are, they'll add together and be C. So I want to solve for C1 and C2. I want to maybe solve for
You want to solve for C.
C. Now there's several different ways to do that, right?
I'd say use the 2x.
So the bad part about where we are now is there's almost too much to use. And if you use too much, you're going to kind of start doing... Somebody came and told me they were putting stuff in and they just kept getting circular logic. Like it kept saying B equals B. And you're like, thank you so much for that. That was yummy. So you got to be careful about overusing stuff. You have to make a decision. You can solve for C here or there. Don't do both. Solve for one.
So 2x.
Here, what's C1 equal here?
D sine x.
D sine x over sine b.
Yeah, C1 equals D sine X over sine B. I like it. What's C2?
So D sine x
Yeah, D sine X
over sine A.
over sine A. I like it. Which one of these? 1, 2, 1, 2, 1,
Sine
2.
2x.
They're
They're both
sine.
Oh,
2x.
2B.
One.
Do this one, okay. So if I solve for C, what do I get?
Sine 2x.
B sine B.
No, B sine 2x.
Over sine B.
B sine 2x over sine B.
Yeah.
I love it. All right, now, the other important part of this is, all right, first is this exploration. You have no idea what's supposed to happen, so you just write down every relationship that you can. And you know they're all true, so you can use all of them amongst themselves. Then you kind of realize that, so I want to solve for C somewhere, I want to solve for these guys, kick ass, right? So that was the motivation for why I did this. And of course now, the reason I did that was so I could actually set this up using what the hell all the C stuff is.
Yep.
So now I can write D sine X or sine B, got it, plus D sine X or sine A must equal, that's C1 and C2, must equal B sine 2X over sine B. Get in there. Now something to let go of here is this is not an identity, right? This is an equation. Do we know that that's a true equation?
Yeah.
Of course we do, because we just set up all the freaking equalities. We know it's true. So I can multiply both sides by sine B, for example, if I wanted to. And now you start to say, okay, maybe I'm getting close to the answer. So you kind of look at the answer. What does the answer not have that I
A D.
currently have?
S.
No, well, I know, because I called it...
Oh, wait, yeah, that's right, it's D.
Well,
That's
D, but it
cosine.
still doesn't have a D.
No, the answer has an S. That's the whole point of the answer, right? Of the
It doesn't
question.
have, it doesn't have little a's and little b's.
Yeah, but I currently don't have little a's and little b's, and the answer does. And I have sine A and sine B, and the answer
Doesn't.
does not. So then, what does that kind of motivate me to look for?
Figure out what A can equal and B can equal.
Yeah, look for something that tells me how I can replace. Oh, there's the connection between the sine of big A and big B, and little a and little b. So, this is the hardest thing to do as a math student, is to let go of there always being a recipe-ish way to do something, or a direct way to do, or how I even want to say this. You look for what makes sense to try to do next. So right now, I'm getting closer to the answer, sort of, because look over there, I got b sine 2x. And what's sine 2x? What's the identity for that?
So 2 sine cosine.
So let's go a little bit further with this. D sine x over sine b plus d sine x over sine a. Let's take my word for what this actually says, apparently. Equals, how do you rewrite sine 2x?
2
Sine x cosine x.
And what happens with the sine x's?
They
Cancel.
cancel.
They cancel. Now look at where we are. 2 cosine x b. Okay, that looks really a lot. Holy shit. Compare it to where I want to be. So don't compare where you want to be to where you are at the beginning of a problem. Very often that will only mess you up. Start putting things together, and then when you're done some stuff, look at the answer and go, okay, I'm starting to get closer. Kick ass. Now, real quick. I don't want sine A or sine B in my expression there, right? Because the answer I want to get to doesn't have it. So one quick way to kind of get rid of both at once is if I can make a ratio of like sine B over sine A. I can figure out what sine B over sine A is. And this is why I said, if I multiply by sine B, what's going to happen here? What do I have right now? Let's rewrite this a little bit. D over sine B plus D over sine A equals 2B cosine X over sine B. Look what happens if I multiply by sine B. What happens?
D plus.
If I multiply by sine B,
D sine
goes away here. Here it goes away, so I get D plus D times
sine B.
sine B over sine A equals 2B cosine X. And what's sine B over sine A?
Sine.
That goes down, that goes B over A. So that's how I get rid of the sine stuff that I don't want, replace it with the little letter dudes that I do want. Now there is no way in hell that, not for any problem like this, there's not problems like this. What the hell? Each problem is going to have its own kind of like way to set things up. You write what you can, you look at the relationships that are true, and you work from there. That's the only generalization you can make here. You can't say, is this a problem like example 7? No, there's no example in the book like this. How big would this book be if they had an example? Like every problem that you're going to see, it would be infinitely big. Holy shit. So and how expensive is it when it's not even close to infinity? I don't want to think about, it's about infinity dollars and 28 cents.
They came out with Google for that.
Yeah, Google is our infinite book. So we're almost there. What can I put here now?
A, B.
The B over A. And you're basically, believe it or not, you're basically there. You solve for D. How do you solve for D? You make D plus D is 2D. Yay. Don't do that shit. Good. I'm glad you had the very skeptical voice. I still get people that do that though. 2D. Yay. This is D plus D times shit, so you got to take a D out. Divide by the stuff you don't want. You're almost there. I'll let you guys finish it up from there. No C shit. No C shit. It's always. Anyway, all right. So that kind of problem, I can't get you guys to understand this enough. Do not beat yourself up if you weren't sure what to do with that problem. It is a different kind of problem than what you're used to. But one point of this class is actually to get you used to that kind of thinking, to get you out of that mindset that, let me look at the example. No, you're getting to the point where there won't be examples for every damn problem you see. There are going to be problems based on the ideas that you were taught. This problem is still nice because it gave you the hint of what to start with. Okay. So anything else from homework stuff? Yeah.
Is 1 of 5 pretty much the same though, or you just
No, it's different.
1 of 5?
So rectangle beams, blah, blah, blah. Show that cross-sectional area of the beam is modeled by the function that where theta is as shown in the figure. So they give us a couple of examples of how it could be. So you just want to find the cross-sectional area. So to find the area... All right. Has everybody got what they want from this? Probably more than you ever wanted. Okay. Great. All right. don't know about you, but now when I think Batman, I'm going to think Big Ass Triangle Man. It's going to sound like a They Might Be Giants song. Biggest Triangle Man, Biggest Triangle. All right, so let's see. We have.
I think you lost everybody with that.
I don't care. Apparently, I'm a math teacher. I'm used to losing people. So they tell me that this diagonal is 20, and what I can control is this angle here. Now, of course, what do you have to love? We're back in like early chapter 6, right? Because here's nice right triangles, rectangle, right? How do you find the area? What do you need to find the area of this thing? Don't overthink it. What do you need to find the area of a rectangle? Yeah, the length and the width. So what's this here?
L.
Okay. Now can you be a lot more specific?
It's the base. Or the width.
Are you guys at the point where this is the x piece? So which trig function is going to give you
Cosine.
cosine? I love it. So it's just going to be 20 times cosine.
Yes.
I keep saying that kind of thing because I want you guys to be at that point where the x piece is just going to be the cosine theta times this. Cosine theta is like the percentage that's in the x direction. So of course, what's this going to be?
20 sine theta.
20 sine theta.
For some reason, I'd just been thinking that it was the cross-section of the entire area of the circle.
Oh no, they're saying.
Yeah, they're saying-
Oh yeah, they're cutting the beam out of. Okay, not the whole.
Yeah.
That would almost be too easy then. There's just a big
Well, I was
circle.
trying to figure out how that would relate to sine.
Gotcha. That would be harder. So what do you get for the area then?
400 sine.
400 sine theta cosine theta. Now of course, what do they have?
200 sine theta.
Because that's
Yeah, because what do we know that sine theta cosine theta? What's that related to? What
the
identity?
angle for sine.
If I had two of those, 2 sine theta cosine theta is
200.
sine 2
2
theta, right? And that's what they have in the answer, right? So if I put a sine 2 theta here, I need to borrow from this guy
200.
2.
Yeah.
So what's really here?
200.
200. So another way to write this is 200 times 2 sine theta cosine theta,
So,
right? So that's sine 2 theta. Pop, and that's how you get there. Right? So they gave you that piece in the answer. So nowhere near the last problem, right? Just a little bit faster to get there. So part A, and then part B says maximal cross-sectional area, blah, blah, blah. Sine U achieves its maximum value at pi. We all know that. So if sine of theta is maximum at pi over 2, when is this going to be maximum? Beautiful. Pi over 4. Because twice pi over 4 is pi over 2. So if sine theta is max at pi over 2, because what's sine of pi over 2? 1. All right, good. And 1 is the biggest value sine can have. So sine theta gets its maximum at pi over 2. So sine of 2 theta has to max out when 2 theta equals pi over 2. So that means it would be pi over 4. Or if you put a pi over 4 in here, what do you get? Sine of 2 pi over 4, which is pi over 2. That's going to be the maximum, yes.
I followed you on the first one.
So if theta is pi over 2, sine, if the inside, let me say it this way. If the inside of sine is pi over 2, it's maximum. Is that cool? If what's on the inside of sine is pi over 2, it's maximum. So here, if theta is pi over 2, it's maximum. Here, if 2 theta is pi over 2, the thing inside the sine. And what would theta have to be? Divide by 2?
Okay.
Pi over 4. And so blah, 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 blah. Which is, and to be really honest, I don't know why they made such a big deal out of that. Now I really look at it. What's the biggest that could be? What's the biggest sine of anything could be?
1.
1. So what's the biggest that could be? 200. I don't know. I just looked at their hint, thought it was necessary. Completely unnecessary. Okay.
Since you're on, can you do a touch-tone telephone?
Where were we at? Oh,
108.
oh yeah. Okay. So the 4 key. Okay. So the first part of this problem. This is number 108. First part's easy enough, right? Okay. How do you see that? Response. Let me see. So pressing a key produces this. This is 108.
Is this 7-3?
Yes.
Yes. There it is, okay. Blah, 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 blah. So part A just says find the function that models the sound produced when the 4 key is pressed. So the 4 key is related to, what's F1 for the 4 key? 770? And F2 is?
1209.
1209. So part A is easy. Just plop those in there. Cool. Yeah, it was a function of t to begin with. The F1 and F2 are known as parameters. In this case, somebody just got to tell me what those are. The t is allowed to vary as time. I can let t go from 0 seconds to whatever. Part B says use a sum to product formula to express the sound as a product of a sine and cosine function. So you just look that bad boy up, right? That's one of the ones I didn't make you memorize. So you just go back and look at sum to product. What do we have? We have the sum of two sines, right? So the very first one in there is how to handle the sum of two sines. So that's for part B. Right, this should be relatively easy. Okay. I like that you're all looking this way. But you have this weird, zombie-esque look to you. And if your phone went off right now, that would really...
If it did,
If it did.
but it won't.
Good.
Because I actually turned it down today.
No way. They got brains. So graph the sound wave generated by the 4 key, blah, blah, blah. Okay. So is that, was that get you enough? Who asked that question? That's almost done, right? Okay. So it's just a plug and chug thing from there for the product to sum formulas. Or the sum of the product in this case. All right. Anything else from homework? So here's this. Quiz tomorrow. Yay. All right. Here's what's going to be on this bad boy. Remember, this next test, which is happening when?
Next week.
Next Monday. Exactly. Holy crap.
So we have a class on Monday?
I asked you like a week ago, you said it was the Tuesday. You said it was...
Hell no. No.
You said...
Yeah, you said you're not going to give us a test on Monday after we...
You said...
After we get back? From where?
I just remember you said...
One other reason's got to be on a Monday is so I can actually grade the damn things. So I actually have a little bit of time on Monday afternoon. Tuesday I got no time. So that's too bad for you guys. So quiz tomorrow.
So we're doing the review on Thursday?
Section 6.4 through 6.6, plus there'll be an identity problem. So remember, this is law of sines, law of cosines, but also inverse trig stuff. Yeah. Because I think the last test we stopped at...
We did 6-4.
We did 6.4 in the last test?
Yeah.
Oh, okay. So we'll do 6.5, 6.6. So law of sines, law of cosines, and prove an identity problem. Kind of thing from the first few sections of chapter 7. Okay, good. Then you don't have to react like that.
That's a good reaction. I'm excited. I thought it would cover more.
Give them an idea.
All right. So anything else from homework?
Are we going to have a quiz on Friday?
That would be really good. Right. Nobody showed up? Yeah. Jess?
I was confused. Number 17, 7.3.
I know, right? I doesn't even check to see if I learned anything. What is today?
Oh, okay.
I just
All right, good.
deal with
This will be a good review.
Which way to put it today?
Number 17, right? 2 cosine 3 theta?
Yep.
So we gotta put it-
All right, guys, this is from section 7.5.
Oh, shit, let me see. Oh, yeah.
So I have a bad feeling that I'm not getting any questions about these because nobody's got to them yet, possibly.
Oh, I-
Or they're
I do
really
like-
easy.
No, I do like 2 of them, and then I get mad and I stop.
Yeah.
Yeah.
That's about right.
So that's when you should ask.
No, I understand what to do, I just get mad at how long it takes, so I stop.
All right, so
I divide that by 2 first.
Not that one.
don't make me bring out my old man stories. When I was a youngin', we didn't have
I walk
TI
15
84s.
miles to school.
We had TI -1. Didn't do shit. All right, so what's the first step here?
Divide by 2.
That's crazy. Divide by 2.
Oh, yeah, this one.
What happens here?
It
Am
stays the
I,
same.
am I currently worried about that?
No.
And of course, the question kind of gave the answer away. But yeah, I'm not worried about that until the very end.
Yep.
So right now I'm looking at is 2 cosine angle equals 1. So if I divide by 2, I can then figure out what that angle has to be.
Yep.
So you're supposed
Primarily, right?
Yep.
So you're supposed to just make it look like it's cosine theta equals 1.
Yeah, you think that
And
way.
then-
3 theta is an angle. Here's a triangle with the angle 3 theta in it.
Okay.
So I'm going to figure out what 3 theta has to be. And then once I know what 3 theta has to be, I know what theta has to be. A third of that. That's the whole idea. So don't even let that in there bother you. Please, dear God, don't try to use some kind of identity to rewrite this. Holy shice.
Oh, if it makes you feel better, I definitely went to 8-1 when I get frustrated with that. So.
Okay, all right. Yeah, that made me feel a lot better. So what are my answers? How many primary answers am I going to get? What quadrants am I in?
1 and 4, yeah.
Yeah, definitely in 1
Yeah.
and 4. That's for cosine's positive.
Yeah.
So where's the basic answer in quadrant 1?
5/6.
Yeah, well, cosine's got to be bigger. It's going to be smaller
Pi
when
over
it's
3.
further away from the x-axis because cosine likes x, right? So it's got to be pi over 3.
4.
5/9 would be.
Oh, eventually, yeah. I'm not worried about it yet because I haven't even finished that out yet.
Plus 2 pi k.
Exactly. All right, we can do that. So that's plus 2 pi k. So that would be this answer and then all the ones related to that. Now what's this answer? How far back behind 2 pi is it going to be?
Negative pi over 3.
Pi over.
Pi over 3 back from it, right? So what's 2 pi minus pi over 3?
Pi over 3.
5 pi over 3. You guys, silent majority there back there. You guys with me?
Pi over plus 2 pi k.
Yeah. So that's 5 pi over 3. And then you give it its own series of rotations.
Could you?
Oh.
Could we write it as like negative pi over 3 plus 2 pi k? Is that
That's acceptable. I mean, I said the other day, I wasn't. This is fine. Because what's the k do? What can k be?
anything?
Any integer.
No, not anything. Any integer. So it could be forward rotations, backwards rotations, but a full rotation each time, right?
And then-
So it doesn't really matter. I can put anything here that's relative to one of these, and the k will capture everything else. It still will. It'll just go back a few rotations or something. Okay?
then
All right.
divide by 3.
And then divide by 3 and you're done. Yeah. So if I divide by 3, so I get theta equals
Pi over 9.
pi over 9 plus,
2/3 pi k.
yeah, 2 pi over 3k. Theta equals 5 pi over 9 plus the same damn thing. And why is it not? What would this guy's period be?
A number.
2 pi over 3.
Yeah, remember that? 2 pi over 3. And what we add? That's crazy. We added, in the first place, we put his period there. Because if I go a full period, I know I'm going to capture the same value again. Well, once I cut it in thirds, it's the same idea. It's going to have to add a period's worth of rotation, and it's going to capture the same value again. Yes, sir.
I was just wondering, for 7.5, you said 5 through 60, every 3 other.
Oh yeah, so that one we said earlier, we put it up here, so this is section 7.5, it should be 5 through 60, every 5th one. Right. To be honest, I did that on purpose just because of me. Just so you know.
Man.
Catch my bagel better.
If you haven't gotten there yet, you feel great. If you've already done it, you can feel however you want to. Right, you should have asked.
Web sign.
WebAssign, I had it every since one of it.
Yes, you did.
I kind of knew what it meant. I didn't realize it wasn't written right. Is that decent? I mean, if you're able to solve without anything in there, this is just one extra step at the end. And then what else could they ask you? I don't think this problem asks you this, but what if I ask you... Oh yeah, it does ask you this.
What's the answers between 0 and
Yeah, what
2
would
pi?
part B says, okay, between 0 and 2 pi, what are all my answers?
When you find your common denominator and then plug numbers into A.
Yeah, exactly. Right. So I know I've got pi over 9,
Plus 6 pi over 9.
and then what am I gonna? I can make this.
6 pi over
Yeah, exactly. So 6 pi over 9. So I can just keep adding 6 pi over 9 until what happens?
Until you get to 2 pi.
Until I get past 2 pi. Right? I'll probably go past 2 pi. So if I add 6 pi over 9, does everybody see where 6 pi over 9 came from? Mm-hmm. Yeah, just making like denominators with this guy.
7 pi over 9.
Cool. So then, yeah, 7 pi over 9. We're making a list first off of these guys, and we'll make a similar list off of these guys.
13 pi over 9.
And that's still not there yet, right?
No, 19 doesn't go.
Yeah, because 2 pi would be 18 pi over 9. The next step would be past that, so I can stop.
With that one.
With that. And then you make the list with that one. So you start here at 5 pi over 9.
12. I'm sorry, 11.
11 pi over 9.
17.
And that fits, and that's it. Yes, sir.
So I've noticed when I'm doing these that there's, like after the first one, there's pretty much a pattern. Is that always going to be the case?
Yeah, in fact, you can see it. Well, you can't see it between here, but obviously it's going to. You just mean a pattern from here to here.
No, I mean like even that you can see, from there's a plus 4, 7 pi plus 4 is 11 pi.
Oh yeah, between there too,
Yeah.
exactly. But
So
you can't
you-
go there.
No.
Good.
Well, eventually you can, because then you see that's plus 2, and then it's plus 2, and then
Well, that's plus 4, plus 2, plus 4, plus 2, plus
that's
4.
what I mean. Yeah.
Exactly. Yes, that all.
But they always have a pattern like that.
Why do you think so? Because the basic shape of these graphs we're
Never
talking about
changes.
are.
It never
Yeah,
changes.
yeah, and once you smush it, it's never. We're not to the point where we can figure out how to make it do something like that, and then woo, and then go, you know, where it's changing based on where it is. We only know. I don't know what sound it makes, but we only know. Okay, I start with the basic sine function. If I change the period, it changes everywhere, right? So then everything is equally spaced still.
Yeah.
So when you start messing with things and start making it so that the period itself changes as you move along, that's where things get freaky. But right now we're not there. They're always going to be equally spaced, so you're always going to be able to find some kind of patterns all over the damn place with trig functions.
Okay.
It's
Yeah.
so cool.
It's cold?
Mm-hmm.
Okay.
What?
All right, so let's see. So before we get back into where we stopped last time. Oh, holy crap.
Yes.
That took a long time. All right.
Sorry.
Not long enough to like that.
Dang.
What I want to focus on today is graphing a few trig functions.
Graphing. What, a polar?
Yeah, maybe we'll graph one. Yeah, graphing polar.
We're not graphing trig, we're graphing polar.
What's that?
Never mind.
Boom.
You confused me.
We're graphing polar, not trig, right?
Or are we graphing trig with polar?
Everybody uses sticky notes.
It's in the book.
What are we doing?
Remember we did the rows yesterday? This is one of them.
I love you guys so much. So if you were here yesterday, do you remember what we did at the end?
The rows.
Or did you create multiple personalities to siphon that away, that memory?
Plotted points.
I want to speak to... Yes! So when I say we're going to focus on graphing something today, I probably mean those. You can choose to do that. I'd say it's probably a bad idea in general.
Oh, the butt thing.
Yes, the butt thing. Whatever gets that back in your brain.
So we're not plotting them by hand, we're doing them on the. Oh no, we're doing it by hand.
Yeah. All right, here you go. Here's a little present for you guys.
Another one?
I've got the take that.
You need to do web, you need to get on Blackboard so we can save the paper, save the environment.
And you're going to just draw on your screen. That's what you're going to do.
Can.
Yeah.
That works.
And then bring your monitor here.
No, we should email it to you.
Email me your screen.
It's called screenshot. Yeah. I know you're old.
Okay, stop. Stop graphing. Stop graphing.
All right. And before we, well, let's see. Now we're going to tag this straight.
What section is this? A2? Or the rest of A2?
So let me take one right out of the homework for you guys to try out. Yeah, section A2. Remember on page 552 they have a collection of generic shapes. So let's try this here.
Jeez.
Oh yeah, let's try this here. Alright, so what I want you to do, if you weren't here last time, it's not that freaky. Theta is my input, R is my output. So we're just going to let theta be some nice values. The reason we're going to get our decimals, we're going to change these into decimals, but the only reason I'm picking nice angles is so I actually can plot them on my angle scale, right? So you certainly want to use 0, pi over 6, pi over 4, pi over 3. You can try to be a little smart about values repeating. This one's going to be a little hard for that because sine and cosine are positive and negative in different areas.
Yeah. Which one? Yes. Yeah.
All this technology.
What? What'd you say? Why would it be plus 1/2? Yeah. 2 points. Roughly. Just 2.73.
Alright, just want to put a couple of these down, make sure everything's right. Just take out a 1 decimal place, I think it's
Okay.
pretty good for
Graphing.
graphing. So I guess the basic idea is pretty straightforward. Plotting these things, we just got to get used to the new coordinate system.
It's 2. Because it's 2 red 2, 2's canceled, so it's red 2 plus red 2.
So how many coordinates should we do on this?
4. 2.82.
So 2.8. Just 2.8.
That's not going to be enough, right?
No, because you gotta get the negative.
Again, you got to differentiate between a problem that is semi-long versus difficult. You're just plugging stuff in and getting values. The next step would be plotting that thing, and that's the only really new kind of thing for us.
It's 2.7. The next one is 1 plus 2 again.
Yeah.
Continue the next step.
So they do the negative.
So now we go 2 over red. 2 over red. After plant 2 would be red. 2 over red 3. Or 2's 5 over 3. Yeah.
Yeah.
Would be. Which one is negative? Cosine is negative. One minus red 3. No. Red 3 minus 1. Yeah. Red 3 minus 1.
Don't know.
Hey, you want to try to rotate? No, please.
Cosine is, if it's 2, if the reference angle is pi over 3,
Yeah.
then cosine. You see what I'm saying?
Oh,
Same thing, okay.
I said, I don't know what they're saying. I
Don't listen to
understand what he said.